Hi guys, so we are back again and talking about systems of equations. This information is on the last worksheet, worksheet 17. So far when we've talked about systems of equations, we've talked about solving them by graphing. Graphing is a great way to visualize the intersection point on systems of equations or the overlap of the shaded region when we're talking about systems of inequalities. But it's not always the most convenient. We can't always come up with a graph and nor do we have time sometimes to do the graph. So we need to figure out some ways that we can use our algebra processes. So one of the algebraic methods that we use is called substitution. Excuse me. So we have substitution method here. We have our steps here that we need to go through for substitution. I'm going to actually jump back up here for just a moment, just to remember that we have three possible results when we're solving systems of equations. We have one solution, right, where that's where the lines would actually cross. So we'd have the two, choose blue here, right, so this would be a situation where we would just have one line go in one direction, maybe another line go in this direction, and we'd have that intersection point. So there's our one solution. We also have a no solution, right? And if you guys remember on the no solution, we're really talking about parallel lines. If we have two lines that have the same slope, they're going to go the same direction. Those lines are never going to cross. Therefore, there is no intersection point. So that's what we're talking about with the no solution. And then finally, we have a solution that's called an infinite solution. And that is when we would basically just have the same line, right? So if we had this guy here and we had another equation, a second equation, but it had the same slope and the same y-intercept, those would actually be on the same line. And the reason, of course, that we have an infinite number of solutions, we can visualize an infinite number, excuse me guys, an infinite number of coordinates all along these lines. Okay, so those are the three possible results when we're talking about solutions. All right, let's continue talking about this idea of substitution method, which is an algebraic method. So really what we mean with our substitution, we are going to be subbing one value in for another. Okay, we're going to be taking a value, let's say, what does x equal in terms of y? So it's got y's in the result of that. And we plug it into the other equation so that the other equation just has y's in it, then we can solve for y. Because we know we cannot solve for x and y. If we even look down here, there's no way that we could solve this equation and get just one number because we have two variables. So we have to do some substitution and try to just trick it. It's kind of a tricky way of getting to our solutions. So we are going to be isolating one of the variables in one of the equations, and then what we're going to be doing is substitute that variable's expression into the other equation. Then we can solve the equation. Okay, so we're going to get one value. Let's say maybe we're solving for y in that situation. Then we're going to go back to this idea of substituting, so we can substitute that value back into any of the equations to solve for x. And then, of course, we always write our answer as an ordered pair, so we always have an x and a y. And that solution means that at that point, that x and y point, is where those lines intersect. All right, so let's practice this idea. Let's go ahead down here to example number 1. so this particular example is set up very, very well for substitution. You notice that this first equation, we'll call this guy equation number 1. We're going to call this guy equation number 2. Let me turn off my frog pump here. It's very loud. I've got frogs, and the little fogger sometimes acts up and starts going crazy. All right. You notice in equation number 2, the x and y are not on the same side. Okay, so it's telling us that x is equal to this value that's in terms of y. So our job is then, if we're looking at the fact that here's an x and here's an x, and in equation number 2, we have what x is equal to in terms of y. So we can just take this value, y plus 1, and we are just going to plug it in to that first equation where we have that x. Okay, so this is what we're going to do here. So first of all, we're going to plug for our x. So we have this value, y plus 1, which is our x, right? And we're going to continue with that first equation, plus y equals 4. This is just this equation here. And now you can see everything is in terms of y, which is beautiful, so we can actually solve for it. I have 2y plus 1 equals 4. And just go through the algebra process here. And I get y is equal to 3/2. All right, so I have one of the coordinates. So far I've got this guy, right? I've got the y. Now I just need to plug for my x. Okay, so let's go back here. I'm sorry, I said plug for x, plug for y. Hello. So we know that y now is equal to 3/2. So we can go back up to this equation, this second equation here that's already in terms of x. I'm just choosing that one because it's easier. You could choose either one of those equations, but this one is already in terms of x, which is great. X is equal to, now we have this value for y. So we have 3/2, right? And then I'm going back to the original equation, which was plus 1. This was where my y was sitting. X is equal to y plus 1, so x is equal to 3/2 plus 1. Okay. And we have some addition of fractions, so we're going to change that 1 into a 2/2, which is the same as 1. And we can see that x is equal to 5/2. Okay, and in the end we write our solution as an ordered pair. So my x value is at 5/2 or 2.5, and my y value is at 3/2. And of course you can check, of course, by plugging that back in, right? You would take your 5/2 and you would plug that back into your x in both of those equations. You would take 3/2 and you would plug that back into your y in both equations, and you would just make sure that this solution here works in both of those equations. That's how we check. Alrighty, let's do another example. Let's take a look at example number 2 here. Now this one is a little bit more difficult, not too much, but you notice over here we already had this one right here. We use just a different color so we can kind of see what we're talking about. This equation right here was already written in terms of, it says x is equal to y plus 1, right? It was already isolating our x. Over here in example number 2, we don't have one yet that has one of the variables isolated, but that's okay. This is actually a pretty easy one to isolate our y, since the y is already by itself. So we can move this 2x to the other side. And we'll come up with the equation y is equal to negative 2x plus 6. So now this is going to be the equation number 1 that I'm going to be using, and we'll call this one our equation number 2. All right, so in this particular case now, you can see instead of in example number 1, we isolated our x and we plugged in here for the x. Well, now we've got a y value, okay? So what that means is in this equation right here, I'm going to be plugging in what y is equivalent to. Okay, negative 2x plus 6 is what y is equivalent to. That's what this equation tells us. All right, so let's do that. Let's take this guy down here. So 3x plus 4 times what we know y is equivalent to in terms of x. And finish this out, so that's equal 4. And now you can see this entire equation here is just, the only variable in this equation is x. So now we can go ahead and solve for x. It's like we've got some distributing to do here. So we've got 3x, and we're going to have a minus 8x plus 24 equals 4. Negative 5x subtract our 24 from both sides. So negative 5x is equal to negative 20. And after dividing by our negative 5, we can see that x is equal to 4. Okay, so we have our x value, and now we just need to find our y value. And we can see once again that equation number 1 is set up very, very nicely for that, right? It's already in terms of y, so y is equal to negative 2. Now instead of putting an x in there, since I already know what x is, I can plug my 4 in. So y is equal to negative 8 plus 6. Therefore, y is equal to negative 2. And voila, we have our ordered pair for negative 2. So this is saying that in this system of equations, at 4, negative 2 is where these two lines cross. And once again, we always want to try to check those. So you literally are going to go back through. I have a little more room on this one, so I'll show you the check real quick here. So this was our equation number 1. And you can use your original equation, that's fine. So 2, we know that our x is 4. And we said that our y is negative 2 equals 6. So that's an 8 minus 2. And that one definitely checks out using our ordered pair. Equation number 2. 3 times x, so 3 times 4 plus 4 times negative 2, which is our y, equals 4. This is going to be 12 minus 8, and that one checks out as well. So we can see that our solution of 4, negative 2 checks out in both of those equations, which it has to do. If you ever do a check and your solution does not work for both equations, that means that is not the correct solution. Okay, guys, I wanted to take a look just at 2 more examples from your worksheet. Goodness, I have a frog and I cannot get rid of it. All right, let's take a look at problem number 1. This is not your example. This is now onto the problems. Problem number 1. All right, so this is kind of nice because we can see here that we already have a value for y, right? So we know that we can just go right up to our first equation and substitute that value in very quickly. So let's do that. We're just going to bring this guy down here. So we've got 3 plus 2 times 5 equals 31. So something very odd happened here. You guys can see that our variable completely went away, and we're actually left with this statement that is simply not true. Okay, so when you're solving by substitution, if your variable disappears, okay, then you know that this is a no solution. It just doesn't work. It means that these lines never crossed at all. Okay. All right, so that's kind of interesting. Let's take a look at number 7. Whoopsie. Number 7. All right. So we can see here in this example, we have one of these equations already that has isolated y for us. It's telling us that y is equal to 3x plus 2. Therefore, I can go to my other equation and plug that amount and plug that expression in for y so that I can solve for x. So I'm going to take my 4, and instead of y, I'm going to be putting my 3x plus 2 in there. So I've got 12x plus 8 minus 12x equals 8. 12x minus 12x is 0. So my variable disappeared here as well. However, we've got this true statement, right? 8 is definitely equal to 8. When that happens, when your variable disappears but you're left with a true statement, that's called an infinite solution. And what that really means here, guys, if we even went back up to this step, I know I crossed out the x's, but basically it's saying that it doesn't matter what value we put in for x, this is always going to be true, right? If I put in a 1, you can see it's 12 minus 12. If I put in a 2 for x, this would be 24 minus 24, right? It's going to work no matter what I put in there. Whereas up here, this is a false statement. It's never going to work. There is no solution whatsoever. Okay, guys, so that is it for this video. I just wanted to go through the substitution method with you. You guys can see on your worksheet you have a few of those to try yourselves. You can go ahead and use your solutions if you need them. And I'll see you in the next video where we will be talking about the elimination method. All right, talk to you soon.